Hello, everyone. This is the presentation of our group's solution for the finance solution as we specified in assignment 2. So in our solution, as per our infrastructure diagram here, we have 4 sections that we are going to go through one by one. First of all, we have the networking section, and then we have the storage section, the security and notification section, as well as the IAM, user management, and key management section. So I will go first and present our networking setup. So as the user enters and access the application, their user traffic would be directed to the CloudFront distribution. So this distribution would help with the caching and the latency for the user traffic, and it will sit in front of the Elastic Load Balancer to share the load across 4 EC2 instances in an auto-scaling group. So, and those EC2 instances are set within different VPC. So we have created 2 extra VPCs for this solution, one for production and one for non-production. We do not use the default VPC that comes with this account. So the production VPC has the CIDR of 10.1.0.0/16, and the non-production one has 10.2 instead. As you can see here, here's the subnet setup. We have the private and public subnet for production, as well as some RDS private subnet just for the RDS servers in production to increase security. So the public and private subnet takes up the /24 CIDR of 10.1.1 and incrementally. And the RDS private subnet takes up the /25 CIDR with 10.1.5, etc. We have also set up the route table for each of these subnets. So each of these route tables are very simple. They just refer to their VPC CIDR as the local target. And here, as you can see in the non-production one, we have 10.2 as the local target. Each of the VPC also have internet gateway for, of course, both production and non-production. And they have peering connections from production to non-production for cases such as data replication from prod to non-prod for testing. We have not set up any NAT gateways because these cost a little bit of money and it will eat into our budget a little bit too much. And each of these subnet will be associated with accordingly the network ACLs. So we have restricted all traffic except for HTTP and HTTPS traffic, as well as, for example, we can deny a particular IP address if it's a known harmful attacker, for example. Each of the EC2 and RDS instances also have their own default security group so that they only allow these respective EC2 and RDS instance to connect to them. So that was the RDS to EC2 security group, and this one is the other way around from the EC2 to RDS. In addition, we also have S3 endpoint set up for production and non-production, so that traffic only goes through AWS private connection. Next up, I will hand over to Manu to show us the RDS setup and storage setup.
Okay, thank you, Huang. Hello, I'm Monil Gurung, and I was responsible for the storage and data architecture for our AWS-based cloud security project. My focus was on ensuring data was stored securely, efficiently, and in compliance with industry and standard using AWS services like S3, RDS, and DynamoDB. So first of all, we'll look at the S3, Amazon S3. So We used Amazon S3 to store transaction log, backups, and CloudTrail data. Here, let's look at the Monil transaction log bucket, which is hosted in the Sydney region. This bucket had a server-sided encryption enabled with AWS KMS, and public access was blocked to maintain data privacy and compliance. And we also have added a lifecycle rule named archive to Glacier to automatically transition objects to cheaper storage tier. So this moves older files from S3 standard to IA and eventually to Glacier. This saves cost while still retaining historical data for compliance, which is especially important in finance, where long-term record is required. So this is the archive to Glacier table. And the next one is the Amazon RDS database for the core data. For structured data like user details and transaction records, we deployed Amazon RDS with PostgreSQL. We launched 2 DB instances across different availability zones for high availability stimulation. Both instances are isolated with the private subnets with strict security group rules and encryption SSL connection. We also followed AWS best practices like automated backups, parameter groups, and using IAM integration for better security control. And the next one is the Amazon DynamoDB. So we also use DynamoDB for storing fast-moving real-time transaction, and we created 2 tables, production DynamoDB for live data and non-production DynamoDB for the testing. So inside the production table, DynamoDB table, so there are so inside the production table, each item has an ID, transaction amount, and transaction details. So for example, one record shows $1,000 hardware purchase and another is a $10 coffee expenses. So these entries stimulate how a back-end system might log transaction in real time for analysis or fraud detection. We use on-demand capacity, which means the table scales automatically based on the load. And that's it for my part, and I'll next transfer it to Nicholas.
Okay, so I'll be doing security, the security section. This section includes CloudWatch, simple notification services, and CloudTrail. For CloudWatch, this is a dashboard, which is one of the key services used in the security architecture. The reason for CloudWatch is to create an alarm. This alarm at the 50% threshold of CPU utilization, it will give out a notification and send the alarm. The EC2 this type of alarm helps administrations identify performance or potential security issues and before they escalate. The real-time monitoring helps ensure our applications remain available and compliant with the services. CloudWatch also integrates directly with SNS for automated notifications and with CloudTrail for logging specific events, overall ensuring that we can continuously track system health, detect threats early, and respond efficiently to incidents. Next up, I'll be talking about the notification service. The notification service here I created is called prod EC2 events. It's configured to receive alerts directly from CloudWatch. This setup allows our team to stay informed whenever an event or alarm is triggered within the AWS environment. For example, when the CPU utilization increases 50%. As shown here, all 4 group members are subscribed to this topic using their email address. Each subscription is confirmed, meaning we will instantly receive an email alert whenever the CloudWatch detects abnormal systems activity. This ensures that our response to performance or security indicates that it is both fast and coordinated. The final topic is AWS CloudTrail, which is mainly for monitoring the framework. The event history, you can see the event names, the event time, the user, and the event source. So names here such as a console login or create trail can be seen here, and what time each item is done. This is so you can see the exact timestamps for visibility. It's essential for security auditing and forensic investigation, so we know who does what and exactly when. CloudTrail also is integrated with CloudWatch and SNS, so all 3 are integrated together to make sure that if any real-time triggers an alarm, you can see for what reason the alarm was triggered by the events. And yeah, that wraps up the security segment. So I'll be passing it on to Nathan.
All right, so I'm Nathan, and my part of the project focused on implementing AWS Identity and Access Management, Key Management Service, and CloudTrail. These services control who can access our resources, how data is encrypted, and how all activity is audited. So this is our IAM dashboard. So first step for me was creating the user groups. So I created 4 user groups based on job roles. So we got analyst, compliance auditor, developers, and finance admin. Each group has permissions that match the principle of least privileged. So for example, our finance admin, they've got full access to Amazon RDS. While another user group such as like auditors only have read-only policies for CloudTrail and S3 logs. This structure keeps administrative access separate from audit and development tasks, reducing the risk of accidental data exposure. Next was our users. So I then created individual IAM users and assigned them to their groups. Every user has unique credentials, which allows auditing of individual actions and supports compliance requirements for accountability. So the users here are analyst user, compliance auditor user, developer user, and finance admin user. So if you go into analyst user, we can see the permissions. They've got full access to Amazon Athena. Compared to the compliance auditor, where they only have read-only access, as shown here in the permissions. So next step was the roles. So I created 2 roles, the first being EC2 fraud detection role and Lambda payment validation role. These were for services that need temporary access, which is why I use the IAM roles. So our EC2 fraud detection role lets EC2 instances read from the DynamoDB and sends logs to CloudWatch, while the Lambda role securely accesses RDS for payment validation. Using roles prevents us from embedding long-term access keys inside applications. Each role has a defined trusted entity, meaning only that service can assume the role. Here we can see the permissions for our EC2 fraud detection role, where once again, only got read-only access, so they can't modify or edit anything. Next, we got our policies. So I wrote a custom policy that denies any upload to S3 unless it's encrypted with KMS, named deny unencrypted S3 uploads. Here we can have a look at the JSON file that I wrote, which once again just denies any unencrypted uploads. So going back to our users, in our finance admin user, under like our security credentials, I enabled MFA, so multi-factor authentication, using an authenticator app. So MFA essentially just protects administrator accounts even if the password is stolen. So here we can see the MFA, which is actually linked to my phone, similar to any other MFA. It gives a code or gives like a push notification to allow access. It's just that second layer of security. So then going into our key management services or service, I created a custom key for finance admin user, which is a symmetric KMS key, which encrypts sensitive data such as our S3 buckets, RDS databases, and CloudTrail logs using an AWS's managed encryption. And then finally, in CloudTrails, we have payment audit trail. So this was used to record management events across all regions. Logs are stored in an encrypted S3 bucket, and log file validation is enabled to prevent tampering. This provides us with a complete audit trail of who accessed which resources and when, which is critical for regulatory compliance and incident investigation. So in summary, I've implemented the IAM structure, MFA, a KMS encryption key, and CloudTrail auditing, which together these components create a secure, auditable, and compliant environment for our financial application on AWS. And that wraps up our presentation. Thank you guys for listening.